So we'll go to the next session. So now we will continue with the subplot. Once the subplot is over, then we'll go to Simulink and then Arduino. Okay. So first of all, in subplot, as I already told you, in the same plot, when you want multiple graphs to be drawn or multiple plots to be done on the same window, then what we have to do is subplot is used. Subplot 2, 1, 1. In the sense 2 into 1. So there will be a plot there, 2 into 1. That is 2. It will be only 2 plot. 2 into 1 in the sense there will be only 2 plots. Okay, in that the first plot. Huh? मैं ऐसे कर लेती हूँ because actually मुझे इसमें MATLAB दोनों में cross करना है. So here if you see subplot 2, 1 in the sense you will have a plot in this plot you will have 2 plots. Like say in the figure window there will be 2 plots. So if one is 2, 1, the first element, that is 2, 1, 1 means the first. In the first one it will plot. Then 2, 1, 2 in the sense it will plot in the second one. So it is something like this. If it is 2, 2, 1, in the sense 2 into 2, 4. So there will be 4 plots. If you write subplot 2, 2, in the sense there will be 2 rows and 2 columns. In this case, 2 columns and only 1 row. Okay, so that is how it is done. So we'll see an example, then you will understand clear. So now in this example, we have to draw 4 plots. Okay, so it is 2 into 2. Like that, so that 4 plots can be drawn. One is voltage versus current. So here you can see V versus I. So where V is given 4 into I and I value is 1, 2, 3, 4 on it is given. Then plot Y versus X, where Y is X squared. Then you have a plot like T is equal to 0, 2 pi in step T. T is pi by 60 and plot sine T is given. And next is T is equal to 0 to pi in the steps of pi by 30. That is 2 into pi, 0 to 2 into pi in steps of pi by 30. So now again we have to plot. So these 4 plots are there. These 4 plots we have to do in 4 separate graphs. So in order to do that, so the commands are this. I'll just explain the commands. Here you can see I is defined. In this case, you can see for the first plot, I is defined, V is defined. And I am just making a subplot. Subplot is 2, 2, 1. In the sense 2, 2, in the sense there are 4 plots. 4 plots are made. So in this 4 plots, the first plot, that voltage into current will come. So there are 4 plots like this. This the first 2, 2, 1 is the first one. This plot I, V, title and X label, Y label you will do. Next again X and Y plot 2, 2, 2. In the sense this one 2, 2, 2. Then again 2, 2, 3. This one will be plotted. This is the subplot this. And again you will give the plot command T, sine T, plot this. And then last is subplot 2, 2, 4. In the sense this is this one. So for that plot T, cos of T. So this one we will just now execute and see. So first of all, I'm just doing only 2 plots. So you can see here, only 2 plots are coming here. 2, 2, 1. So only 2 plots have come. And next, the remaining program also I'm just putting. So automatically you can see here 4 plots. So you can see the voltage and current, parabolic plot, plot of sine function, plot of cos function. So you can see the position accordingly. You can have, say here, voltage and current was the first, then was the parabolic plot. So parabolic plot was this one. So this is correct. This one voltage, then parabolic plot, then plot of sine, that is 3, and this is your 4. So when you want to do 4 plots, you can do it like this. So this is for subplots. When you want to have subplots, you go for this. Then there are different other plots also, two-dimensional and three-dimensional plots. Some of the plots are the bar plots, the stair step plots. So all these things I already told you. You can go to the example and you can do it. So here, just let me just help you out in pasting this. So x value is given minus 2.9 to 2.9 in steps of 0.2. Now you have to draw the bar. So you can see here, bar is the command with x comma the variable. So here, in this case, x comma, this one you can put it in y also. Y is equal to exponential of this, and x comma y also you can give. So in that case, you can see the bar graph here. Okay, so here once you close this graph figure, this is x and this is your bar. So this your bar graph is here. Okay, the x value is defined and your bar is given. So automatically you can x is given and bar is given and you will get the value of bar. This is your bar graph. Similarly, next we will see the stair step plot. There is a staircase. In that case, again the x value is defined. Okay, x is defined, x is x to 10 steps of 0.25, stair of x comma sine of x. So x comma y also you can put where y is equal to sine of x. That is also possible. You can do it like that. So here in this case, you get a step like this, sampled signals. In order to sample it, you can do it like this. Then you have error bar plot. So error bar plot, let us just plot and see. This is mostly used in statistics where ERF, that is error of the function, what it does is it just takes the Gaussian function, it will just find the error with it and corresponding error and it will plot it. So here you can see the x value, y value and the error, random error and the error bar. Error bar is the plot that is used for plotting the error in statistical analysis. So here this is the error plot. You can see here, this is the error plot. So after that, polar plot. For t is defined, then polar of the whole variable x comma y you have to give. Okay, so here you can see t is given, polar of x comma the y the variable as such, instead of y they have given absolute of sine 2 into t dot star cos of 2 into t. So this is how it is given. So if you can see the polar graph here, so this is the polar graph. So you're based on your application, you can go for different plots. One is the stem plot. So again in sampling, mostly the stem plot is used. X and y is there, stem of x comma y. In Fourier analysis also, mostly you can see this. So this is your stem plot. Okay, and the last one I'm just taking the color map. So color map, maxima minima, this will be a very helpful in GAPS and all. You can plot this and see this plot. So this plot gives you where is the maxima existing, where is the minima. So in GA, whether you have achieved the maxima or minima, all these things you can understand it from this plot. So this is the mesh plot of peak. So Z is equal to peak of 25, mesh of Z and color map HEV. So this I already told you, you need not worry. In order to learn these things, go to help, go to 2D, 3D graphs or anything. You can go to any location where which one you want to learn. You can go and learn. Say if you want to learn fuzzy logic, go to the fuzzy logic help here. In help you have fuzzy logic. Go to fuzzy logic and there fuzzy logic toolbox examples are given. You just go and open the script here. Okay, the script file is here. The script file you just open this example. So this example fully, this is some kinematics example, modeling inverse kinematics in robotic arm. So the example is given here fully. So what you can do is open this example. If you give, the code will be opened. For all the examples, the code, see this is the code opened here. It's an M file, the whole code is available here. Okay, the whole full code is available. Now what you have to do, go to the editor, just run this program. inverse kinematics underscore this. So this you have to just run it. So it is inverse code starting training first ANSYS network. So it is some ANSYS adaptive neurofuzzy inference system network it is taking and it is operating it. Okay. So it is, I think I did a big mistake taking a big program. It's starting the training and the program is going on. Okay. Anyway, it is running fast. Starting the, it is an ANFUZ, adaptive neurofuzzy model has been taken and it is training the network. Okay, so you can just take any program which is already existing. So when you see the program, sometimes it seems that you can't open it. What you have to do there is you have to go and open that model. Once you open the model, you will get the code. Once the code is there, automatically you can start running it. So now it is almost over and you can see all the K1, K2 values and all these things here. Okay, and the graphs are also have come here. Okay, anyway, I don't know the program, what is it? I simply opened a program and I just showed you. But there, what you can do is, you can just go and read what they actually have done it here itself. What is inverse kinematics? What is ANFIS? Say they have given all the things here. And data generation, how they have generated the data of the arm. And step by step, you can just run this portion. You will get the graph. So step by step, you can fully do it and see. Okay. So and here all the graphs would have generated fast, and we got this graph at the end. Okay, so you this model, if you want to have an animation also, that is also possible. You have to for the animation you have to go to this link and you have to operate it. So here many such examples are already existing. You have to just open, say this is gas mileage prediction. So this gas mileage prediction, also open this program and run it. Sometimes it will take more time. So I'm just, no, I don't want to waste my time here. So that's why I'm not going into it. But you can just go into any examples what you want. So you want some embedded coders, DSP systems, or for curve fitting toolboxes, data acquisition toolbox, or robotic controls, or you have your SimScape, coders. So in SimScape itself, under SimScape, you have your you have Sim electronics, Sim power systems. You have many other things coming under SimScape itself. So next is, now we have seen a lot of coding. Okay, now I will go into some graphical application, that is nothing but your Simulink environment. So in Simulink environment, there I'll just show you, this is the Simulink library. I think all of you can see the Simulink library here. So this is the Simulink library. You have to just click on this Simulink library. And in Simulink library, almost all the toolboxes are already there with all the functions and all the block sets. Okay, so here whenever you want some blocks, you have to just drag from there and put it into your system and reconnect it. So I'll be just showing you step by step, but learning the Simulink, there are some basics. You have to know some few things so that Simulink will be very clear. So one of the thing is nothing but your making a subsystem. Say you have a very big system. You have a motor control system. In that, first you have to make a motor. Okay, then you will make a controller. Then you will have a controller is nothing but it will be at a very low voltage level. It will just give you control signals. You have a power circuit. In the sense, you will have some thyristors or some relays to turn on or turn off the motor. To control it also, you have some power devices there. So all these things, when you simulate what will happen, it will be a very big mess there. Motor, when you want to simulate, it should have a field winding, it should have an armature winding, it will have number of brushes, this. All together, once you simulate, that itself will come to 2 pages. Then controller, it may be any type of controller inside PID controller, or it may be a microcontroller based controllers. So all those embedded programs, it will take the voltage and current, it will compare, do a lot of things. So all these things, once you put it in a single sheet, you itself will become confused what is what. So what we do, we make subsystems, make a motor, select all those things and put it inside a block and we say that is a motor. Then power supply and all the accessories, we put it inside and we say that is the power circuit. Then we put all the control circuit inside one. Okay, and that PID controller, or it may be a current controller or anything, we put it inside. It may be eddy current based controller or fractional controller, anything. Put it inside a block and say that is a controller. Now connect these three. You will understand. If you want to change something inside the motor, go click on that and you go and change it. So you know what is where. Okay, so that's why we have to make a subsystem first. Next is masking a subsystem. You have some concept. So now anyway our window is open, it takes little time. So here this is the Simulink library. All things commonly used block, if you see, say you have a constant, you want some data type converters, you want a gain, you want this, all these blocks are already existing. So what you do, you just a new model block. When you want to open a new model, a small icon, this is the icon which you have to remember. Okay, so this icon, if you click, automatically a window will open. In that window we will just drag all these things and go and put it there, and we will reconnect it. Okay, so this is the window. So what, say now, for example, simple thing I'll show you. I'm just putting a constant. I am putting two constants. Okay, and I want to add it. Some logical operators is wider. I want to do addition or subtraction, like that. Say I'm just putting this multiplication. Okay, so here let me give, just double click on it. I'm giving some variable 3. Apply. Okay, so now I want to find the sum. So here element wise multiplication, this is for multiplication. If you want addition, you can just go and take addition blocks. So all these blocks are available here. This is commonly used. Those blocks will be available in math operation. Okay, in math operation, if you go, you will get all the mathematics, say dot product, all these mathematical function. Addition is this for adding two numbers. If you just double click and make it minus, you can add one and you can subtract. So these are the things. So now you can just multiply these two and you want to display it. So display all those things which you want to display will go into the sink. You have something called source, and similarly you have something called sink. So when you want to see the display, you can just take a display, connect this, and just for running the program, you have to just click on this run. So automatically it will run and give you the answer here. So 1 into 3, it has to give me an answer 3. So it is displaying the answer 3. Okay, so here you can see this is a simple thing I showed you. Okay, so here one thing what you see, when I double click on this, a window will open. Okay, and it is asking me what is the constant value. Okay, so similarly let me take some other block. I just want to show you a concept called masking. Okay, so masking, why do we go for masking? Say I told you here itself, when we clicked on this constant, a window opened and it was asking me what is the value you want to enter. Okay, similarly in this also masking, say for example, if I want a motor, I can just click on this and here type it also. I can click on this window. I can click on this window. Okay, this is paused, that's why, sorry. Okay, so here, let me say I want a thyristor. When I put a thyristor, automatically here in the new versions, this is after 13, I think, 13 or 14, you have this option where you can just go and click on the screen itself and write it there, like write half of the name, it will give you the option what is available, THY. So if a thyristor will come. So let me select a thyristor and click on it. So automatically your thyristor will come there. So after that, once the thyristor block is here, if I double click on this, a window will open. If I double click on this, a window is opening and it is asking me what is the value of resistor you want to keep. What is the inductance you want? What is it for? So this is nothing but a masked window. Okay, this is masked. This variable resistance is masked there. I have not given any value inside. I have just given a variable A. So that A variable, I am just defining that resistance, or say RON was the variable which was defined inside. So now I can give that variable as 0.001. So that is nothing but called the mask. You're masking a variable and you are entering the value. So now we are just going to see some important concepts like what is a subsystem and what is masking, how to do masking. Okay, this is already masked, inbuilt, already existing element I have taken. Okay, now we have to see how to do all these things, how to make a subsystem, how to mask a subsystem. So for that, let me first of all, before going into it, I am just going to take a small example and do all the concepts which are available in Simulink with a simple example. Okay, for understanding purpose, the example what I am taking is a simple example which all the field people can understand. You're from electronics, electrical, mechanical, or even from in 12th standard itself, you would have learned a concept of rectifiers. Have you all learned rectifier? Rectifier is that which converts AC to DC. Okay, so now we are just taking an example of a rectifier. I'll just explain the rectifier because many of you, if you don't know also, you will understand what is a rectifier. And then we will go into the concept of what is masking. So for a rectifier, say I have some diodes. I am taking 4 diodes. It's a bridge rectifier. So I am taking 4 diodes. Okay, I am giving a supply for this. That is an AC supply. So you are using this every day. This circuit you are using every day. This is, say, in your mobile. Your mobile charger, you go and connect it in your house to 230 volts. So that 230 volts is this. Okay, this is the 230 volts. But your mobile, once the output of the mobile is say 5 volts or something for the battery of your mobile. So you just think this is the input supply, it is getting rectified, and this is your load here. Your load is nothing but your battery of your mobile. Okay, so it is a mobile charger. Just think this is a mobile charger in between. Your load is the battery. So here you want DC. This is 230 volts AC supply. This is your AC, and here you get some DC voltage. So this is the simple circuit. So now what you are going to do, as I already told you, you have given AC supply. So in India, the supply is 50 hertz. Okay, 230 volts, 50 hertz. So this is the supply. And once, say, during the positive half cycle, here when the positive half cycle comes, this diode, say, let me keep it as 1, and this is your 2. And let me keep this is 3, and this is my 4. So what happens? This 1 and 2 are forward biased. This is your anode, this is cathode, this is your anode, cathode. So during positive half cycle, these two are forward biased. So this supply will come to the output here. Same output will come here. So you will get a output this. Okay, this has output. Next half cycle, during the negative half cycle. During the negative half cycle, when here it is negative, what will happen? This 3 and 4 are forward bias. During that time, these two are reverse bias because negative supply is coming. This is your anode, this is your anode. So these two are reverse bias and these two are forward bias. So what will happen? Across the load, this is forward bias and this is forward bias. Across the load, again you get a output like this. This one gets shifted up. So this is said to be full wave rectifier. You get DC output. AC has become DC. So this is what is happening in your mobile rectifiers, like in your mobile chargers. You get DC. So this is said to be pulsating DC. It is not a constant DC. Okay, then using a filter, a capacitor or something, you can make this constant. So this is what we are going to do here. So here, during first half cycle, during this cycle, what was happening? 1 and 2 was forward bias, 1 and 2. Okay, so that firing power that has become for 1 and 2 was forward bias. That's why you got this. And during this cycle, 3 and 4 was on. Now what I'm doing? In these diodes I am making as rectifier. Sorry, these diodes I am making as thyristors. This is just to show you the concept of masking. Okay, you will understand why I am making it as thyristor. So thyristor is that which you can control at any instant. Here in a diode, what will happen when this becomes positive? When this becomes positive, automatically diode will get turned on. But thyristor, even if it becomes on, it will not get turned on until you don't give a firing to this. So these two are forward bias, but it will not get turned on. So let me take that after some 45 degrees, that is 45 is this point, I am turning on this T1 and T2. Here at this point I will be turning on. In the sense I am giving here a firing pulse at 45 degrees, that is for 1 and 2 to turn on. So how will be my output? After 45 only I will get my output. Similarly 3 and 4 I am just firing after 45 degrees. So here to here again I will fire. So my output is controlled. It is not giving me the full output. So this application where you will be using in our fans. Say fan regulator is there. That is nothing but a thyristor. So what you do, you just don't, when you want to reduce the speed of the motor. Here when you want to reduce the speed, full voltage will not come. Only a reduced voltage will come. So automatically when you get a reduced voltage, fan speed also will get reduced. So that is an application. So here, say here I am giving firing pulse at 1 and 3. Again next positive cycle I will be giving it here. Similarly, another thyristor, this is for thyristor 1 and 2. For thyristors 3 and 4 I will be giving a firing pulse here and I will be repeating the firing pulse here. So again I am telling, don't get confused like why ma'am is teaching all these things. I am just teaching you to tell you some concept about what is subsystem and what is masking. So here if you understand this, I can easily explain. I will be doing the circuit and I will make a subsystem and show. Same thing in your circuit also you can do it. Okay, so here I am just turning on these two thyristors at this firing pulse and I am repeating the firing pulse at every positive cycle. This is a positive cycle, I will be giving a firing pulse. So again 1 and 2 will get turned on here. Okay, so here now I have to tell my computer at what time. This 45 degrees computer will not understand. I have to tell my computer at what time. In terms of time I have to tell. So what is this time and what is this time? And what is the time at which this should repeat, that I have to know. So we know that 50 hertz, this supply is 50 hertz. 50 is your 50 hertz is your supply. Okay, so what is time? Frequency is nothing but 1 by T. Okay, 1 by T is nothing but your frequency. Frequency is nothing but 1 by T. So your time for frequency is 50 hertz and your time is 20 milliseconds. 1 by 50, that is 20 milliseconds is this whole cycle. So this whole cycle is 20 milliseconds. Okay, this whole cycle is 20 millisecond. So this whole cycle is 20 millisecond. Then half the cycle is 10 millisecond. Then this 3/4, like 90 degrees is nothing but 5 milliseconds. So 45 degrees, if I say it is 2.5 milliseconds. So when should I fire this? I add 2.5 milliseconds. And what is the firing angle? This one for 3 and 4. This is 10 milliseconds. So this is 2.5 milliseconds. So here I have to give 12.5 milliseconds. So here I have to give 12.5 milliseconds. 3 and 4 I have to fire and I have to repeat it at 20 milliseconds. Every 20 milliseconds, because here if I fire again negative, the same point I have to fire again. So every 20 milliseconds you will repeat it and you first delay will be 12.5 milliseconds and here it is 2.5 milliseconds. So computer will understand only in terms of time. So whatever thing, even if you are controlling a lathe or you are controlling an aerospace application, you have to give it in terms of time. You have to say fire this motor or something. So for actuator is required to turn the space shuttle. Okay, at one particular time you have to fire. So what is the time? How will you give? In terms of time. You have to convert everything in terms of time. So the system will have a clock there. Say the clock, you are using a microcontroller or something. It has a clock frequency of 16 megahertz. So accordingly, you have to according to the clock time, you have to calculate at what time you have to fire a particular thing. So that here, in this case, if it is 50, say supply which is coming is 50 hertz, we know that it is one cycle is like 50 hertz in the sense the AC makes 50 cycles per second. 50 hertz in the sense it makes 50 cycle per second. In 1 second, it is oscillating 50 times. Okay, so this time you are just, so if, one cycle is 20 milliseconds. In every 20 milliseconds, it is making one cycle. That is how, for any problem, you have to calculate it properly. Calculation is very important. So this is okay. Now the same problem, we are going to do it in MATLAB. So for that, I require a thyristor. So I'm just taking a thyristor. I showed you thyristor. So I'm just taking the same problem only. I'm just doing it little fast because we are going out of time. I'm just copying this. You have to just Control C, Control V. If you do, you can copy this. And now this is over. I require a AC voltage supply, AC voltage source. So I'm just taking a AC voltage source. You have to just type what you require there. Okay, once you start using this, you will become little more familiar. I'm just connecting all these things. This is just to show you the concept of subsystem and masking. I'm doing this. Okay, so AC supply is here. I'm just connecting my AC supply. So here I have to come and give the value. So AC, I told it is 230 volts. So 230 volts and frequency is 50 hertz. So 50 hertz. Apply. Okay. Okay. So the other things, values are already there. I require a load. So let me take an RLC load. RLC series branch I want. Okay. So this one, Control R, I'm just rotating it. I want a current meter. That is nothing but an ammeter. So measuring the current. I require a voltmeter, voltage measurement. Okay, I am just copying that here also. You have to just drag and put the elements and connect it like this. With the wires, you have to connect it. It is very simple. So I've connected the voltmeter. Now all the voltmeter ammeters are there. I want a scope to look into. Scope is like a CRO. Okay, just I want a scope, but how many elements I want to see? I want to see 1, 2, 3. Apart from this, I want to see the pulse generator also. To generate the pulse. So this is the pulse generator. I require 2 pulse generator for 2 thyristors. So have we said P1 and 2 require the pulse? This is what I said. When I made so many, I am itself confused where are the things. Is it? So that's why we make a subsystem. So this is a rectifier. This is your source. This is the source voltage will come here. Okay. Source voltage, you will get it here. This is the pulse generator for this. And this is your thing. So scope, how many I want to see? Let me see some 5 parameters in the CRO I want to see, or a scope I want to see. So you have to go to, in scope, when you double click, a window will open, and here you have a option for parameter, which I have clicked. So that one I have to just click, and number of axes I am just converting into 5 axes. Apply. Okay. So automatically you can see 5 axes have come here. So what all things I want to see, I can see it in this scope. So let me see this voltage. Let me see the source voltage, the load voltage, current. Then let me see the pulse generator. So all these things I want to just note it. So which all things I want to note, I have just, all the things which I want to note, I have just drawn it here. Okay, so all these things are here. So now what we require, we just want to, I just want to tell you the concept of how to make a subsystem, and next is how to mask a subsystem. So for that, so here what is a subsystem? How to make a subsystem? You have a source, you have a load, and you have the CRO to look into the output. So I just want this item. This is my rectifier. So I just want to club all those things, put it inside a single window and say that is my rectifier. So in order to do that, I have to select only those elements. So in that elements, you can see a measuring port here. So if that port is not required, you can use terminators and terminate it. Otherwise, all those ports also will come. Or what you can do, you can just double click and show measurement port. You can just remove it. So that port will go. Otherwise, when you make a subsystem, these ports also will come there and it will confuse you. How many ports will be there. So you can just, I'm just removing it, or whenever you have some extra terminals like that, you can just terminate it. So I've terminated it. I just want to put all these elements into one and make it as a subsystem. So let me connect these things. Okay, only these things I have connected. This is the rectifier. I am just clicking right. What I have to do, whichever elements you want to put it in a subsystem, connect that. Okay, so that one I have connected and keep it over any element. Right click on that. Okay, when you right click, automatically a window will open like this, and here there is an option for create subsystem for selection. So what you will do, you right click on it and create subsystem for selection. That option you just click. So automatically what happened, this is a subsystem. So you have a subsystem here. So this is your input. You have your input here coming from the AC voltage, and you have two things. One is this is your load. Your load is connected here. This current meter is going, and this is the other end of the load. And what are these things? These out 1 and out 2 you are seeing. This is the pulse generator output. I had a pulse generator inside, is it? So this is the pulse generator 1 and 2, the pulse generator output. What I can do is I can remove this here. I can remove these two, and you can go inside and see. So these connections also got cut because these are little confusing. So I have removed it. So how to bring the signal out? So what I can do, I can use to go to blocks. So put go to tag. So go to blocks. So you can have two go to blocks and just connect it to this. Okay, so this one you have to name differently. So let me name it as B. And one more thing you have to remember is, when you are taking this from one subsystem to another subsystem, inside you have to mention local as global. It should be declared as global. Otherwise, outside it will not be seen. Okay, so here you have put go to blocks. Now you can see here, I will go and add the from block here. So go to A and B, two variables I have defined, that will come here. So from block, put from, just click on this, you will have two blocks. Okay, you will have two blocks. Just click on this and connect it here. Here and here. These are the go-to blocks. So when you click on this, say A. Okay, now update the tag. Okay, so it is not showing anything. A, you clicked OK. Similarly, B also, you can just name the variable B. Apply. It is when you apply, nothing is coming. It's not showing the tag. The reason is, say, I'll just run and show you. This will not run. It will show me an error because all these elements, it require one more block called the power GUI. I'll tell you about the power GUI later. So now let me run this. So when you run this, you can see there. See these two blocks, there are no outputs coming. So now, what is the reason these two outputs are not coming? Because it's not getting a link from inside. So for that, what we have to do is, we have to go inside this go to tag, click on this, and this is a local. Once it is local, it can be seen only inside this subsystem. So make it as global. and apply. Refresh. Okay. So now you just click on this link. See, you will get a link here and it will show you where it is going. It is going outside the block and it's coming here. Similarly, for the B also, you have to go inside, go to this and make this as global. Until you don't declare it as global, it will not be seen out. So here you can see it is B. So these two variables are coming out. So now little settings are required. Those things I'll do. I didn't do any setting. First, for the pulse generator, you have to do the setting. Is it? What was the period at which the pulse have to repeat every time? 20 milliseconds. Is it? I told you every 20 milliseconds it has to repeat. And what was the delay? 45 degrees in the sense it was 2.5 milliseconds. So 0.0025 was the milliseconds you have to give here. I told you every calculation you have to do it in terms of time and give it, then only it will understand. Similarly, here also you have to define for the other 3 and 4 thyristors. So 20 milliseconds is your period and your phase angle is nothing but again it is 12.5 milliseconds. I showed you that in the thing. So for 12.5 is 0.0125. 1, 2, 3, 5. Yeah, it is 12.5 milliseconds. Similarly, after this, we have to have the settings for this also, load. So for example, say I am having different types of load. If I want an RL load, I'll be selecting that and you can set the values, how much you want. So 40 ohms and I'll just keep some 80 millihenry of inductance, apply, okay. And I'll just reduce the time period for which I want to see the graph. Otherwise, it will be confusing. You can't see all the graph clearly. So I think all of you can see the full diagram. So now what we did, we changed the load, we set all the values of pulse generator and everything. Okay, so now we will just run this program and we'll just see the output. So now to see the output, just click on this and this is the auto scaling. Here you can see a symbol. So this is auto scale. Click on that. Automatically you can see here. So if it is not clear, you can just go and do the parameter setting. You can start as we did in MATLAB, same way you can change the scale, color and everything. So I am just changing it so that it will be little more clear. Thickness, all these things options are available here. Okay. So you can see the graph here. So this was the So you can see the graph here. So this AC supply was a supply, this AC voltage. Then this was a load voltage, which you saw here, this voltmeter. Then you have a discontinuous current going here. That is this one when the inductance value, they say here the negative current is going and sorry, negative power is there in the sense the voltage is going negative in the sense the energy what the inductor has stored is giving back and it is becoming zero. That's why the current is becoming zero. And the pulse, I already told you, this is the pulse for T1 and T2. Okay, T1 and T2, the thyristor which I showed you, that is these two thyristors, like these two thyristors, the firing pulses, it starts at 0.25 milliseconds, then every 20 milliseconds it repeats. So this problem what I explained, same thing we have done it here. Okay, so here our main aim was to show you how to make a subsystem. So in case if I want to put these two into a subsystem as a source, I can just select this, right click and create subsystem. So this will also become a subsystem. I can give here the name supply. Okay, so this is a subsystem. Now next, let me tell you a concept called masking. What is masking? Say when I click on this, a window is asking and it is masked and it is asking me the value for resistor and inductor. In this case, when I click on it, circuit should not open. It should open a window and it should ask me what is the firing angle. Okay, because firing angle is that which I can change. Is it here I kept it as 45? I can make it as 90, I can make it as 180, anything. So that is why I just put it as a thyristor there, just to show you the concept of masking. So for that masking, what we want to do, here also you can mask. You can just go and put this variable what 230 as A. If I put a variable, then it will ask me what is A. Okay, so here in this case, I will show you the block which subsystem what I made. Just double click on it, go to the pulse generator, and let me keep this variable phase angle as A. Okay, and similarly, let me keep this as B. So two unknown variables, I am just keeping it. If you run, it will give me an error. It will tell me, I don't know what is a variable of A and B. If I run this program, it will give me an error because inside this I have kept two variables A and B which can be changed every time. So how will you create a mask? Just right click on this, go to mask, create mask. You have an option called create mask. Again, I'll just show you, right click on it. Okay, and here you have an option called mask. So you have to go into this option mask. Okay, so right click, go to mask, create mask. A window will open. In this window, you have to set all the parameters. So in case if I want to see a picture here and I want to write some variables, say for example, I want a function to be written like this. I want a function 1 divided by z squared. I have made a block of a function. I want a function to be displayed. What I can do is, it is nothing but d poly numerator and denominator term. I have to just give it here and just put apply. Automatically that function will come here. Or if you have made a rectifier and you want to put a picture of a rectifier there, or you have made a lathe or something and you want to put a lathe picture there, or you have made your own function, and for that you can put the images also. So image, the command is image with within brackets single quotes, you have to put the image, any JPG image. You can go and put it in the Simulink link there in C prompt. Okay, and in C prompt in program files, you have the MATLAB. Go inside MATLAB and you have Simulink. Simulink and toolbox will be there. Inside toolbox again Simulink and again Simulink. In that location, or what you can do, go and search for this b747.jpg. It will give you a location. In that location, go and put your own image. Whichever image you want, you can put. So if you put this image there, copy this and put it here. And just put apply, this image will come. Okay, so if one more image is there, I have just put it as a Simulink theme image is also there. So just update it, apply. So the Simulink theme image will come. So any image, whichever image you want to do, if you want to put an aeroplane image, or you want to have a space shuttle, or if it is a controller, you want to put, all those things are possible here. Here, what all command, what we wrote in MATLAB, plot command, everything is working. You can make a plot here also. Anything, whatever plot you want to make, or whatever commands you have in MATLAB, that can operate here. Next, after this, you have to go to this parameter and dialog. So this is a place where you have to define the parameters. Okay. So here you want the parameter to be edit box or your check box, or anything you can put. So I am putting it as an edit box. So I want two edit boxes because I have two things. One is my firing angle 1. So what was the parameter I gave? The same parameter I have to give here. Let my parameter be A. And my firing angle 2 is nothing but the parameter B. So what parameter I have given inside, the same parameter should come here. Otherwise, it will be a mistake. It will show you, it will tell me I don't know what parameter you're defining. Okay, if you want to initialize, say if it is an inductor or some other value, you can initialize those parameters also. What all parameters you defined here, if you want to give some initial value, you can give it here. Then documentation, because now you have made your own block. So you can write some documentation. Okay, you can define this is a rectifier. You can give a MATLAB link here. Anything you can do. So apply and OK. That's it. So now you go and click on this block. This window will open and it will ask me what is the firing angle you want to give. So in this case, if it is 90 degrees, 45 I said 2.5 milliseconds. 90 is, it is around 5 milliseconds. So I can give it as 0.005. And here in this case, it will be 0.05 milliseconds, in the sense you have to give for 10 plus 5, 15 milliseconds, because one half cycle is 10, then again 5. It is 15 milliseconds. So this is for 90 degrees firing. So let me run the program and see. So here you can see now the same problem is for 90 degrees. You can see here it became more discontinuous, and here this portion also has reduced around 90 degrees. This is the 90 degree. So this is 90 degrees. So every 90 degrees the firing is taking place. Okay. So that is what is shown here. So next is, if I want to add some program which I've already written in C, or I have a .m file, already I have a GA program, I have a PSO program, I want to come and embed it here. How will I do it? So for that you can go to the library window. In that library, you have user defined functions. So these are some of the user defined functions. So here you can see, when you want C programs to be, so S function can be used, Fortran or C program, you can use this S function. Or if you have an M file, you can use this MATLAB function. So just now I'll just write a M file and show you how to use this function. So let me use this MATLAB function here. So when I put this MATLAB function, this function will come here, and now you have to just how many inputs and how many outputs you want, you have to define. So just double click on this. So this M file will open. So this is the M file which we already learned before, same M file. So what we did, we actually put that function and we double clicked on it. When you double clicked on it, a function will excuse me. So when you double clicked on it, this function will open. Now you can come and write the code here. So how many outputs I want? Say let me keep that. I want 2 outputs. So I'm writing y1 and y2 are my 2 outputs. You have to put it within brackets, square brackets. And how many inputs you want to give? Any number of inputs. Y1, you want to give say 5 inputs, you can just give it here. So x1, and let me give 2 inputs. So function is u1, u2. Okay, 2 inputs are there, 2 outputs are there. Then I have to define the function. So my output y1 is equal to u1 into some 100. Let me keep it that I am defining my output y1 as input 1 into 100, and my y2, let it be equal to u2 itself. Okay, simple. I'm just, you can write your GA program here, PSO, anything. So for GA, what are your inputs that you have to define here? For what are your outputs you will be defining here? Or if you are using a Newton-Raphson program, your Newton-Raphson inputs will be here, outputs will be here, and your full program will be here. Okay, and this one is default there. It is just for code generation. Like any error is there, it will generate. This is the syntax. You need not change it. This already existing, only your program, you will go and paste it here. So now you can go to the Simulink window. So you can see here, when you run this program, automatically when you run this program, when you run this model, which you have already done it, automatically, so it is running this model, 2 outputs will come and then we can select it. Okay. So now you saw that now 2 inputs and 2 outputs automatically came here. Now we have to give the inputs. So let one voltage be my one of the input, and another current be my another input, and output is scope. Scope is my output. So let me have 2 variables there, axis. So you can see the output here. Okay, so I'm just running this program. So any code, when you have some code, you can have it here. So you can see the output here. Okay, we multiply the input with 100, so that is why the power has gone to 10 to the power 4. Here the output, like the voltage, current is as such taken as Y2. Okay, so if it is a closed loop system, what you can do, you can just go and connect it back to your problem itself. You have a control system, like you have something else, and you want to go and make it as a closed loop system, this output will go and get connected to the closed loop system. So any program which you want, codings which you want to write, you can write it here. So this is the advantage of Simulink. Graphically, you can do all calculations. Okay, Simulink is also a very easy way to do the programming. So these are the two methods, one is using MATLAB I showed you, with Simulink I showed. Now we will go into Arduino. So before that, do you have any doubt in this? Because Arduino also, it will take me at least 20 minutes, 20-25 minutes I require minimum to show basics. So I have time. Do you have any doubts in Simulink centers? Because same thing only in Arduino also we are going to have the same. I'll be using a graphical user interface, same commands and everything. So in this Simulink, till now, Simulink and coding, any problem? Okay, let me finish Arduino also, and at last I'll ask you so that you can give the comments comment for that also. Okay, so first of all, as I already told you, Arduino is a controller. Okay, it's a microcontroller that can be interfaced with this with your MATLAB. Okay, so I'll just show you the Arduino. Sir, वो बैग में एक बॉक्स है छोटा सा. हाँ, thank you. Sorry. So this is your Arduino here. So all of you can see, this is my Arduino. Okay, Arduino block. So this hardware, which you can see on the screen, is a very useful thing for doing projects. Okay, small, any program which you have done in MATLAB can be easily implemented using this Arduino. This is the simplest version of Arduino Uno, you can say. Okay, so this is the, I think, same thing I'll be just showing you in your screen, so that you will be seeing all the input output ports and the controller, everything. I'll be explaining it still clear. Okay, so you can see all the pins. You have here input pins. This side you have the digital input output ports. Here I have the analog input output ports. Okay, A0 to A5. This is the USB port. This is your power supply port. If you want to individually operate it, you can give power supply for this using this. And this is your Atmega 325 microcontroller. Okay, 328, I think, 328 microcontroller, that we will be seeing it in your PPT now. So I'll just show you the PPT. We'll just go into the PPT. There, clearly it will be seen. See my PPT here. PPT is seen here. And in this, here we will be mainly seeing the Arduino with interface, MATLAB with Arduino interface. I'll be just showing you. So this Arduino is a very low cost device. It costs only 400 rupees. Okay, the thing original, it will be around 1200, but now many makes are coming. For Arduino itself, you have Arduino, all these things operate with the same software. So this Arduino is a very cheap controller which can be interfaced with anything. Like you can interface with LabVIEW, you can interface with MATLAB or any other softwares also. Many softwares, this is interfaceable. And not only Arduino, you have Raspberry Pi, Legos, and you have number of other cheap controllers like this which you can connect it with MATLAB. So for that, some add-ons are required that I'll be telling you step by step. So this is MATLAB with Arduino interface. So before going into this, I just want to give you a small story. Because till now, fully listening to MATLAB and Simulink, I think all of them, all their brains are full with technical stuff. So let us now hear a small story. So have you seen this Rhino motors? Any mechanical people, they would have known it. Have you heard of Rhino motors? Any idea seeing this figure? What is Rhino motor? So this Rhino motor is a bike. Okay, that bike which operates with a single wheel. Okay, it is a single wheel bike. So Lawrence, who's standing here, and Chris Hoffman. Chris Hoffman is the main CEO of this company. He is the one who is the founder, you can say. He's the founder of the company. And Lawrence is his daughter. And now we will just see a small story how this company started. So Lawrence, when she was around 6 years old, she is very fond of playing with video games. So she plays this video game. She plays with this video game, Dragon Ball. So once she was going with her father, Chris Hoffman, for a small fishing. So usually in foreign countries they go and for fishing and all, and even India nowadays we people also do all these extracurricular things. So once she was going driving with her father, she was telling, "Dad, you are a mechanical engineer. Why don't you make a bike for me like this, but like the one which comes in the Dragon Ball?" So he has not seen that. He said, "Which Dragon Ball? What? Which bike?" Then she drew this diagram. This is the original diagram drawn by that girl. That is daughter of Chris Hoffman, and which has a handle, a relaxing place for the legs, and a mud guard, and the overall structure is like this. Okay, so now once he told that, he went to the garage. He has a garage at home, mechanical engineer, so he had a small mechanical stuffs out there. So he went and made this prototype. So that's what I said, whenever some idea comes to your mind, before going and implementing as a bike, you have to make a small prototype and check, because this is a single wheel bike. Okay, the single wheel bike, what is the challenge there? When there is two wheels itself, we don't know how to balance, we fall. With a single wheel, a normal man cannot operate it. So what is required is self-balancing is required. The machine should self-balance there. So that was a very important thing. So for that, what he did is the motorbike, big sports motorbike wheel he took, which is little more broader. So that one, it can balance little more. Like with a single wheel, also you can balance. The other thing required is you require some sensors which will maintain the flow of the wheel. Okay, it should not fall, it should maintain the balance. So for that, he used what is called the sensor, and after he used a sensor with some controllers. So sensor was a gyroscope. So this is the gyroscope. So after that, using the gyroscope and this controller, he made a prototype like this. Once the prototype started operating well, he implemented same in the original bike what he made. Okay, so this is how the whole system was made. So first, this is just a motivation for all the teachers there, that whenever we teach something to our students, try to make a prototype or make a hardware or make a model and show them, which will give a good idea for the students. Their students will be able to understand things clearly. So this is not only for electrical engineer, it may be from electronics, mechanical, not only engineers, even the other branches, those people in management or anything, whatever, whenever you do something, some prototyping or some model is very much important, which will some animations also you can make, which will be very useful. Okay, so this is a gyroscope, that is a sensor. Gyroscope is a device for measuring or maintaining the orientation based on the principle of angular momentum. Okay, so here you can see a gyroscope, and in this figure, when you see that here, the center one, this one rotates in the same direction, whatever may be the direction of the outer rims. See, outer rim is moving in any direction. Still, if you see, only the center one moves in the center. This rim always moves in a single direction. Okay, so that is what you can see in this. And a gyroscope in operation with freedom in all the three axes. The rotor will maintain its spin axis direction regardless of the orientation of the outer frame. Whatever may be the outer frame direction, the inner frame will always move in the same direction. So that's how the wheels of the motorcycle also will go in the same direction, whatever may be the outer rim, the outer structure direction. And this can be easily, this is a digital gyroscope that can be easily connected to a Arduino. So with this, when you put it into your hardware, automatically your system will operate. So this is a link where in YouTube you can just go and see this real time. The story which I told you is a real story. So this bike you can go and see in the YouTube, this link which is shown here. So now we'll go to the Arduino. So any controller, it is not that you have to go for Arduino, you can go for Raspberry Pi, Lego, or any controller. So you can see here the Arduino. So in this Arduino, these are the digital input output pins. Okay, you have 14 digital input output pins, and you have PWM pins. The one sign, you can see a small white color line here. So these white color lines are nothing but the PWM generators. Digital PWMs can be generated from that. Similarly, you have analog. Say analog output inputs are there. There are 5 analog inputs you can give. So any types of input, like say the gyroscope which I showed you, or it may be a voltage sensor, current sensor, or any type stress sensor like vibration sensor, all those inputs can be given through these analog ports. Then you have 5 volts input, you can output, you can take it from here. If you want to take some outputs, you can take 5 volts, you want to take 3.3, all these things are available. And this is Atmega 328. So that's the microcontroller which is used here. Okay, so this is the USB port which you can connect it to your laptop, and this is the power supply. So next, this is Atmega 328, 5 volt supply is required for this board. 7 to 12 volts input. Say when you're acquiring some input from a vibration sensor or any sensor, 7 to 12 volts input can be given, is recommended, but it can go till 20, but it is recommended as 12. Up to 20, nothing will happen, but more than 20, it will get burned off. So that's why we give a limit of 12. Don't go beyond 12 in case some short circuit or something occurs. Till 20, it is not a problem. You have 14 digital input output pins and 6 PWM pins, which I showed you. Analog input pins are 6. Then the current, if you see, if you use 5 volts, it is 40 milliamps. And if you're using 3.3 volts input, that 50 milliamps you can get. Flash memory is 32 KB, is static RAM, and EEPROM is there, and clock speed is 16 megahertz. Okay, so here, just like C programming only, here also the programming is similar what you do in C, and other advantages, already the library has all the programs for connecting any keyboard or any Bluetooth device, or for connecting stepper motors or servo motors, and all these things you have already program written. So you need not write program, you have to just pick and drop those programs. So here you can see whenever you write the command, just like MATLAB only, but sorry, just like C programming. But here if you see pin mode, you want to define the pin mode. P is small, M is capital. Digital write, D is small, W is right, and there is no space. So this is how you define the function. Anyway, we will go into the library, and this library of the software, and you can see this. So for MATLAB, when you want to have MATLAB supporting this Arduino, you require a support package that is available in MATLAB File Exchange. If you go to MATLAB File Exchange, in MATLAB File Exchange, MATLAB support package for Arduino is already available. From there, you can download it. So this here you can see the download option. Just click on it, you will get the download. So this Arduino PPT also I have already put in my slide share. I'll be showing my slide share link. From there you can go and get it. Okay, and these are different Arduinos. There are many types of Arduino. The Arduino which I am using is the basic model. Okay, Arduino Uno, Linode, Dio. You have both are a micro, Ethernet, robot for particular application, Mega, or you have motor shield for particular applications. You have for like image processing application, for audio processing, all these things. Many shields are already available. Lily pads are available for robotic applications. Also, you have number of things. So this is one of the small project, real-time hardware project which was done here. That was a inverter. So inverter converts AC to DC. So that was done here. You had a rectifier. This was the power circuit which operates at 230 volts, and this was a controller circuit which operates at lower voltage. Okay, here around 9 volts was the voltage at which this was operating. This is the microcontroller. It's generating microcontroller will just generate firing pulse for these thyristors to turn on. This circuit which I showed you, the same thing, hardware was also done. This was the complete setup which we did in the lab. This was the rectifier. This was the MOSFET bridge circuit. This was the overall Arduino circuit. So pulse, triggering pulses, this was generated in the CRO, and this was the output we got. So we gave DC input Okay, and the inverter, it converts DC to AC. So we got pulsating AC here. So AC supply, but it is not pure AC. It was a pulse, like stepped AC, you can say. You got stepped AC. So in our houses and all, you use inverter. So that there you have a battery. That battery is converted into AC. So this was the experiment we did in the lab. I'll be just doing the same thing in real Arduino and show you. Okay. Before that, you can just take my link here from where you can get the PPT. www.slideshare.net/shimmiregi. SHIMIREJI. So if you go to this link, you will automatically get this PPT from where you can just see the content. Okay. So now let us go to Arduino and do the. So for Arduino, first of all, we have to open the Arduino software. Okay. First, I'll do the software, then we will go into the thing. So for software, so I've just downloaded the Arduino software. Let me see where it is. So here Arduino 1.06, I just downloaded from internet. You can go to the Arduino there according to your operating system, whether it is Windows, and according to the bits 32 or 64, you can just go and download it. So this Arduino is there. One second, actually I couldn't get this. Yeah, it's coming. So this is the Arduino icon. You can see here this blue color icon. Once you go to the website of Arduino and download this software, it's very simple. Go to Arduino. There, according to your operating system, it will give you a link. You have to just download that. Okay, and this window will come. These things are its supporting file. Now you just go and click on this Arduino. The Arduino window will open. And by the time it opens, what you have to do is you have to use the USB and the Arduino. Ma'am, just become. So you have the Arduino and this USB. You have to just plug into your system. Plug the USB into your system. Nothing else. You have to just plug in, and you can see the Arduino lights are glowing, in the sense it has turned on. Okay, you have just turned on. Now we have to just check whether this Arduino is connected in the software. Okay, when the software you have to just check. So now let us go to the software window. So in there, my PPT. So now you can just go to the tools. Here there is an option tools. Go to this tool, go to boards. In that you just see whether Arduino Uno is connected. Our model is Arduino Uno. So that should be connected. Okay. Sometimes if you are using some other model, that will be connected. Next, what you check is go to tools itself, go to serial port and see to what COM port it is connected. It should be connected to some COM port. Here it is connected to COM port 3. If this USB is not plugged in properly, then the COM port will not be shown. So this is also very important. Two things which you check is, once you click on Arduino, you have to go to tools and check whether your board is connected and to which serial port or the COM port it is connected. Two things we have checked now. So now, as I already told you, you can just see the PPT, go to files, examples. In that, all these programs are already written. Many basic programs are there: analog, read serial, the bare minimum, blink, fade, digital programs are there for analog, communication, sensors, display. All these programs are already existing. So what we will do, we will just open a very simple program of basics, blink program. So now the blink program is open. I can just show you the blink program. Okay, so this is for blinking an LED or just generating a firing pulse. So you can see the program here. Here it is void setup. So in MATLAB also, whenever you start a program, you write void. Whenever you don't want to send an argument, like when you don't want to output an argument, you write the command void. So same thing here also, you write void setup, and this is the function which will run only once. Okay, the first void setup will run only once. That is for initializing the pin. So pin mode, as I already told you, P should be small and capital M. 13 pin output. So I told in digital, in Arduino there are 14 pins, 0 to 13. In those pins are digital output input pins. You can define them as either output or input. So the 13th pin I am just keeping, let it be output pin. So pin mode 13 output. Next, again, I've started one more loop, void loop. Again, I'm starting digitally write the 13 pin as high. So I have to write the 13 pin as high for 1 second. Delay for 1 second I gave. Again, digitally write the 13 pin low. Again, I'm giving a delay of 1000, like 1000 in the sense 1 second. Wait for a second. So this program, we will just run it. Okay, it's a very simple program. What we have to run, we have to just upload it. So before this, there will be sometimes there is a problem. Okay, when you have connected the Arduino, you don't know this Arduino is connected or not. For checking that, what you can do, you can go to the device manager. So if you go to device manager, all those hardwares connected to your system, you can you can ensure that your Arduino is connected, because many of you, when you do it for the first time, sometimes your Arduino will not be connected. So in that case, you can go to your device manager and check whether your Arduino is connected or not. So here you can see the ports, COM ports. Go and click on this, say here Arduino Uno COM port 3 is connected. So this is just to recheck whether your Arduino is connected or not. So double click on this, a window will open. Here you can go and see the port setting also. So in this port setting, one thing you have to keep in mind is this bits per second, that is 9600. This is your screen resolution also you have set as 9600. In case your screen resolution setting and this setting is different, then there may be a problem. So you have to just check it whether it is 9600. Okay. So just click OK and just come, close it and come. So it is very simple in order to run this. Now we are not doing with MATLAB, we are just doing it with Arduino only. Just upload this program. You have to just click on this arrowhead. So the compiling of sketch will start. This window is said to be the sketch window. So this compiling the sketch will start and it will upload and the program will start running. So here I'm just connecting the LED, the ground to ground pin and 13 to the 13 pin. So it is uploading, so that's why it is blinking now. So now in the software, you can just go to the software 1 second. You can see done uploading is come. Software. So here you can see the option done uploading. So once it is done uploading, now you can come to the Arduino. So you can see there, once it is uploaded, it is for 1 second, it is blinking 1 second off, 1 second on. Same thing, let me change, come to the PPT. So in this, let me change that, let it be off for a small, only like hundredths of a second. So in that case, I'm just uploading the program. So you can see, now it is the old program. Once it is like uploading, there will be a blink. So in the sense, it is compiling sketch now. It is not uploaded till now. You can see a change because we have changed the program. And now it is uploading. So that's why it's blinking and done uploading. So now you can see it is off for a very small while. Only for a small while it is off and it is on for a larger while. 1 second it is on and for hundredths of a second it is off. Okay, so this is what we have done using MATLAB, with Arduino itself. Same thing, we are just going to do it with MATLAB. Okay, for MATLAB, what is required is there is a support package required. Okay, the support package in the library, let us go to the library, not in the library. I'm just going to my MATLAB file from where I showed you. For MATLAB support package, you have to take it from MathWorks. Okay, that is MATLAB file exchange. So there you can go to, see here, there is a PDF file. This is the file which which I have opened from my MATLAB file exchange, PDE. Okay. In this PDE, if you double click, there is ADIO, analog digital input output. And again, you have a file called adio.pde. So this is the file which is required, which you have to flash into this Arduino so that your Arduino can be interfaced with MATLAB. So this adio.pde file is very important file. So I'll just show you how to go into MATLAB and open this. Okay. So first go into MATLAB, and one thing you have to check is whether your Arduino is connected to COM port. Say serial port, it is connected. Now what we are doing, it will take only hardly 5 minutes. We will finish. I know all of you are very hungry. It is almost 1 o'clock. Only 5 minutes. It's very simple in MATLAB. I'll just show you. We are just going to create a graphical user interface. Till now I showed you the coding as well as Simulink, but graphical user interface I didn't show because I just wanted to show it here. So for graphical user interface, you can just go to Home. In Home, New. Okay, in Home, New, if you go, you have graphical user interface. One option is here. Or you can just go and put guide in the command window. Guide. That is the command. So graphical user interface, I just clicked. My graphical user interface has opened. I am creating a blank GUI. So the blank GUI is open now. So now I have to put, I want two buttons, one to turn on my LED, one to turn off my LED. Okay, so I am just putting this push buttons, double click on the push button, change, I am just changing the color. Let me put a green color for this. Okay, and I can just push button name also, let me change it as on. Okay, similarly, push button 2 also I double clicked. I just put a red color for that push button 2, and I'm going a little fast, I know, because there is we are out of time. You can just go and watch this video later if you want to do it. So I just double clicked on these buttons and I changed the color and the variable. Just double click, this window will open and you will just go and change the color and this. Now in order to edit it, editor is available here. So this editor,
कुलदीप मैं क्लास में हूँ, आप आज आपको कूपन्स लेना है तो आ जाना यहाँ, मेरे पास है मोबाइल में। आईसीटी में नहीं पहुंचा है, मैं आ जाऊंगी 10 मिनट तक।
Okay, so here we have opened this editor. So once you open the editor, you can write the program, because we have put two push buttons. But once I push the first button, my LED should glow on, and when I put the next button, it should turn off. That should happen. So first of all, going into this, I forgot one thing. I have to burn this PDE program into my Arduino. Okay, so I am just my PPT. So first I will go my PPT. So here I will go into my Arduino, open my program, and in that my adio.pd, which one I said, that one I will click and I will open it in my window. So I've opened that, and now I will upload that program into my Arduino. So now this is a program which is already written for making it compatible with MATLAB. So we need not worry about it. That you have to just flash into this Arduino. So it is just getting flashed. So now it is uploaded. Okay, now it is uploaded. The program is uploaded. Now again what we do is, now we can just minimize this Arduino. Okay, now we can, anyway Arduino is ready to get compatible with this. Now we have to go to this editor. So when you go to the editor, it will ask, please save it. So now we have to save it. Let me save it in the location where my PD is there. That is again important, where I have my PD folder, that is which is compatible with MATLAB. So this is the PD. So it should be near in that location. So I'll just name it as some test 1 2 3 4 or something. I'll keep it as test 1 2 3 4, and I'm just saving it. Okay, so this is the program. This is the program which has opened. That is a big program because I have created a GUI. Automatically back end it will write a big program. There are 2 push buttons, and what I have put is come, and baki the remaining program. So for this push buttons, I have to write the coding now. So I have already written the coding here. I'll just explain you the code also. So here clear A. This is a small code. I'll just explain you this after pasting it there. Okay, this is clear A in the sense, once again, one more little more code is there. I'll just paste it. This is for turning on. You'll write digitally write high. So digitally high. As similarly, digital low. Digital low. Okay. So here, you can see in this program clear A, global A, in the sense MATLAB, if it has a variable A, that you have to clear it and you have to globally declare, because this variable is used in other function. A is equal to Arduino COM3. In COM3 port we have our Arduino. I am putting it in a variable called A. Okay, so A is equal to Arduino COM3. Then A dot pin mode 13 pin output. So actually now this Arduino dot the pin mode 13 pin, I am just keeping as output pin. Similarly, A dot digital write 13.1. So the 13th pin I am keeping it as high A dot digital write. Similarly, the 13 pin I am writing it as low. When push button 2 is pressed, digital write 13 pin low. Okay, so this is the program which I have written. It's a simple thing. Other things are same. I have just defined the Arduino port and pin mode I have defined it. That's it. So now I'll go to the editor and just run this program. So I'm just running this program. So it is called this test 123 and it might be connecting it. Updating service code, is coming. Please wait. So once it is there, Arduino is connected, it will come. Then you can just operate on it. So it's very simple. You have to do step by step. That's it. So it takes little time for updating. There is some problem. First, we have to keep a program in that location D where PD is there. So when you're doing the program, you have to be little careful. Okay, so first of all, it is in the PD now. Now I'll just call the test 1234. Let us once again check. Attempting to connect is coming. So we have to check everything. Arduino COM port 3, it is connected. Then we uploaded the program, that is also there. Some small error is coming. Now, anyone, if you have any doubts, because this is a procedure, there is some small error in connection or something. That's why it is happening. Otherwise, say it is now connected. Anyway, say Arduino, is successfully connected. And now I'm just clicking on. You can see the here, like on my Arduino. Okay, so now let me click off. So it is off. Again on. Okay, so I'm leaving it. Now, if I want to say it is now off, then let me again click on. So here you can just control by yourself. Okay, so this now with the buttons I am just clicking it on and off, and I am controlling it. Okay, so this is how you just control it. So it is very simple. Sometimes there may be some connection error, otherwise it is okay. So if you have any doubts, you can ask.